rear trailing arm assembly. So these things right here are very commonly sent out to be rebuilt by a professional shop because basically the bearing preload is difficult to measure. So, or you can otherwise buy a set of tools and bearings to rebuild it yourself from eBay, and it's like $200-300 to buy the tool. If you have access to a lathe or to buy the tool, I made this one myself. Is basically what we're doing. This is the part of the trailing arm that we're looking at. We have the races on either side. Basically what we want is when our axle stub sits in here, we want to have 1 to 8 thousandths of an inch of play from side to side. And so basically what that means is this piece right here that is the assembly tool, and you use this because the bearings can easily just slide on and off. They're a tight fit, but they can slide on and off. When you put the axle stub in, it's a press fit and it's a pain to get back out. But you use this tool because then you can put this in, tighten it down to torque, and then you know what kind of gap there is between the two bearings. You can imagine it sitting in there like this. So what we're doing is we put this in, tighten it down, and then we measure the play, the vertical play between the two as it sits in here, and we want 1 to 8 thousandths. So you do that by changing your shims out to get the right bearing clearance. But anyways, I'm going to go assemble this and get a measurement. It's always good to start big. If you're tightening this down and you don't have any gap in there, you probably want a bigger shim. So start with the big shim, work your way smaller, work down to it. Okay, so I've already done one test fit of this. So I kind of know, I'm guessing these shims are going to be pretty close that I got. And I measured them. I just went to a piece of steel and cut out some shims instead of buying the kit or looking for the right shims. So whatever is going to work, these are what I used. So, you know what they say, whatever works. So I have this on and my special spacer that I made. But it's okay. So here you can see I'm pressing in the bearing on the shaft. And there is a little bit of play, very, very little. So now I'm going to tighten this down. Once I got this all assembled, I'm pressing the bearing to the bearing. Not just torquing down on the hub. But you torque this to the spec. If I'm not mistaken, it's 120 foot-pounds. Could use a vice too, that's how I use it. So I got it tightened down, and there just isn't, it's not loose in there, there's not any play, so it's too tight, so I need to go a little bit bigger. What I figured out was I was putting this in, I was trying to assemble it backwards, so my tolerances were way off. I didn't ruin anything by any means, but I had it together backwards, which dumb move on my part, but hey. So I go to put it together, I'm like, this is wrong, something's off here. Yep, it was. And then I put it together the right way, and my measurements were totally wrong. And I'm right at where the stock parts were when I took them out. I'm really close to that actually. So right now I think my shim is like a 10,000th smaller than what the stock shim was, and I'm at about 5 or 6 thousandths of total play, which is on the upper end. I think I'm going to try to shave that down just a little bit, because I'm just using, I think it's like a piece of 14 gauge that I could have shimmed out of, but I'm going to just sit that on some sandpaper and try to shave it down just a little bit to get myself down to like 2 or 3 thousandths of a gap. I don't know. I just prefer it to be a little bit tighter. I feel like it'll last a little bit longer that way, but I'll show you what I got. So here I got the assembly. This is tightened down, and you can see where that's sitting there. But basically I have it set at 0. I'm at 5 to 6 thousandths of play. So I'm gonna shave it down a little bit more and see if I can get that tightened up. Okay, so what I'm doing here, it's tough to show with one hand, but basically what I'm trying to do, I'm using this rotor because it's the only flat thing that I have as a flat surface. Put the sandpaper on it, and if you look at it, you'll see that it's dirty. I have to clean it out anyways already, but basically what I'm going to try to do, move the sandpaper, I'll show you. But I put a mark on my shim, so I'm going to hold it and run it down the sandpaper a couple times, and you see my mark. I'm going to turn it 90 degrees, hold it the same way, just light pressure, move the same amount of times, and just keep turning it and try to be very consistent with the way that I'm sanding on this, just to make sure that I don't make the shim have a warp to it or be uneven in any way. I'm going to go around a couple times and then see how much I'm at. So I took a quick measurement of my shim with my caliper here, and I got 2.917 millimeters. Well, that doesn't work, so I switched over to inches, and I got 0.115 inches. So I want to take 3 thousandths off of that, so I'm going to 0.112 thousandths of an inch, convert that back to millimeters, and I want to go to 2.85 millimeters. So getting pretty small increments here, but that way I don't have to reassemble it a bunch of times before I know where I'm at. I can just use my caliper or micrometer here and get a pretty good idea of where I'm at, and then test it at the end just to figure out if that's right or not. All right, so I've sanded that shim down for a while, and if you look at reassembled this, and if you look at the clearance, I'm shooting right about 3 thousandths, which I am quite happy with. So keep in mind that these bearings are dry, no grease on them. So now that I have this all done, I get to reassemble and put the bearings, grease the bearings, reassemble everything, and put the hub in, or the actual spindle shaft, instead of this adapter tool that I made. Next video up will be the assembly and rotor run out of these.